Hello everyone, and welcome to your second video focusing on some of our special right triangles. This one is going to focus on the 45, 45, 90 triangle. It's named that because these are the measurements of the angles. If I were to draw one for you, it would look like this. It's a right angle, so that would be your 90 degree, and then you would have two 45 degree angles there. So it's called a 45, 45, 90 triangle. It is also known as the 1 to 1 to radical 2 triangle because that tells you about the lengths of your sides. 1 to 1, so these are the same length, to radical 2, a little bit bigger in order to connect it. So let me give you a for instance of a 45, 45, 90 triangle. Let's say that this is how it is drawn for you. So you have one angle marked 45. You would know that this angle is 45 too because everything has to equal 180. And let's say that you were told that this length is 8. And you were told to calculate the other two lengths. Well, you know that it needs to be a 1 to 1 to radical 2, and you know that your one side is an 8. Your other side is going to be the exact same thing, an 8, because these have to match. So we get to put an 8 there, and then over here, we put an 8 again, we just plop a radical 2 on the end. So this is 8 radical 2. That's all there is to it. Now, it does get a little bit harder. Not all the problems are this easy. Let me give you a harder example. It is harder if they give you the hypotenuse. So, let's draw a 45, 45, 90 triangle. Like that. And instead of knowing what either of those two legs are, we know that our hypotenuse is 10 root 2. So now what can we figure out? Well, we know that the 45, 45, 90 triangle is also called the 1 to 1 to radical 2 triangle. And our hypotenuse here is 10 root 2. So what's our regular side? That would be just 10. Just take that root 2 away. It's just a 10. So there you go. So again, fairly easy once you've seen it before. Now the hardest type of problem that you could face is when they give you a hypotenuse but it doesn't have a root 2 in it. What do you mean? Well, let's have an example. So let's say that this is your 45, 45, 90 triangle, and you know that it is that. And let's say that they tell you that this side over here is a 12. So you see that it is the hypotenuse. And you're looking for a radical 2 because it's supposed to be 1 to 1 to radical 2, and there is no radical 2 there. What in the world will we do? We will not panic. 1 to 1 to radical 2. What should be our radical 2 this time is a 12. How are we going to calculate these other sides? Well, these other sides will be a 12 divided by radical 2. And a 12 divided by radical 2. Because then if I multiplied by radical 2, I get 12. Okay, so what does that mean? So I have 12 divided by radical 2. That is what we call an ugly number. That's the official term. It's ugly. The reason it's ugly is because we have a radical sign in our denominator, and generally speaking, that gives real mathematicians the heebie-jeebies. So we want to get rid of that radical 2. And I don't know if you remember how to do this, but the way we're going to do it is we're going to multiply by radical 2 over radical 2. It's really the same as multiplying by 1. So it doesn't change the value of this fraction, but it does change the way it looks. So now we would have, on the top, we would have 12 radical 2 over plain old 2, right? Because radical 2 times radical 2 equals plain 2, right? The square root of 2 plus times the square root of 2 gives you regular 2. And now I'm going to reduce this. 12 divided by 2 is 6, and I still have the root 2. So each one of these sides is 6 root 2. 6 root 2. And just in case you did not believe me, I could prove it to you by saying that, remember how it's supposed to be 1 to 1 to radical 2? Well, if I did 6 root 2, 6 root 2, and then 6 root 2 times root 2, what would I get? This is going to be my hypotenuse length. Well, 6 root 2 times root 2 times root 2 is 2, so we have 6 times 2, which is 12, which is what we have right there. So you can see how it all kind of comes together. Now, I know that this one is hard, so we're going to do another example. So let's draw ourselves a 45, 45, 90 triangle. And let's say that we know that this side is 20. The hypotenuse is 20. We should be able to calculate the other two sides. So we know that a 45, 45, 90 triangle is in the ratio of 1 to 1 to radical 2. Right? Those are not minus signs. Those are little dashes. Okay, so 1 to 1 to radical 2. So we don't know what either of our legs are, so we have to leave that blank. But our radical 2 side, our hypotenuse, is currently a 20. That means that our single sides have to be 20 divided by radical 2. 20 divided by radical 2. Now, if you were dealing with someone who did not know any better, they might dare to leave their answer in that ugly form, because that is the correct answer. It's just unacceptable, really. Okay, so we're going to do 20 over radical 2, and we are going to multiply it by radical 2 over radical 2. This, by the way, has a fancy name, making this move. This is called rationalizing the denominator. It basically means getting rid of the radical sign, making it look rational again, making it so that even mathematicians can love this number. So we have 20 root 2. I get that just by multiplying 20 times root 2. I write it like this, 20 root 2, over root 2 times root 2, which is 2. And then all I have to do is reduce. 20 divided by 2 gives me 10. And then I still have that root 2 floating around. So each one of these sides is 10 root 2. 10 root 2. All right, let's do one more and then we'll be done. Okay, so let's say we have this triangle. And we know that this angle is 45 degrees, and we know that this hypotenuse is 13, okay? 13. So, let's figure out what we have. We know that this is a 1 to 1 to radical 2 triangle, and we know that our hypotenuse is a 13. So what is this side going to be? It's going to be 13 divided by radical 2. And that's the same thing that the other leg is going to be, is 13 divided by radical 2. So now again, 13 divided by radical 2 is the correct answer. It's just not in an acceptable format. So we need to rationalize that denominator. And I do that by multiplying it by root 2 over root 2. No negatives involved. And that gives me 13 root 2 over 2. Now in this case, you'll see that 13 is not really divisible by 2, at least not evenly. So we just leave it in this form, and you are done.